All right, Unit 8 was short. It was just 2 lessons. It was on the accumulation function and then rates. The accumulation function, we are introduced to this function, some a value to x of some function. Now, if we were to evaluate this, what would we have to do? Well, using the fundamental theorem of calculus, I'd have to take the antiderivative and find the change in this between a and x. And I end up with big F of x minus big F of a. And sometimes you're asked to do that to find a value or find an expression for this accumulation function. But what we typically end up seeing is what we notice is if we took the derivative of this, well, if I took the derivative of this right side, this big F of an a, it's just a number. When I take the derivative of it, it goes away. This big F of x turns into regular F of x. So that means the derivative of the accumulation function is just whatever's inside, with x's instead of t's, because I plugged in the x, I plugged in the a. So this is interesting because what we end up seeing is that if the derivative of this is f, that means this, if I took away the derivative and it wasn't a derivative, this is just equal to an antiderivative. Big F minus big F minus F of a. It's just like the actual function with the constant kind of played into this, which is great. And what we end up doing is we do a lot of function analysis with this accumulation function. And what this essentially means is the accumulation function. Let's keep this up here because this is important. Areas under derivatives equal change in totals. If you know how much area is under a graph of f prime. This is really, if you know this is like 4 and this is 2. Well, f, if you know where to start with, maybe you know that you have the point f of 0 is 1. Well, that means you have to go up 5 to get to 6, and then you go down 2. Up 5, down 2. You know, based on the areas, how much you're increasing, how much you're decreasing. You know if prime's positive and negative, you know you're going up or going down. But now you know how much. And that's really what the accumulation function is. And we took derivatives of it. We did a lot of function analysis. Typically with the accumulation function, you had a graph, and you were asked, like, when is g of x, which is equal to the accumulated area from 2 to x under, make sure you understand order matters, under h of t dt, and you're like, when is g increasing? And you're like, I know when g is increasing. G is increasing when g prime is positive. But you realize the derivative of this is just h. The derivative of the integral is just the function inside the integral with x's instead of t's. So you'll analyze h's signs to understand g prime signs. You'll be asked, when is g concave up? You're like, oh, I know, I got to look at g double prime. Well, g double prime will be equal to h prime. So this is like this table that is created. And, it doesn't matter which function is which. Sometimes you have g and h. Sometimes you'll have f of x is equal to the integral from like 4 to x of g of t dt. Like, don't worry about things like this here. F prime will equal g. F double prime will equal g prime. You can have any variables here. This could be r, and this could be c. You would just say r prime equals c. R double prime would equal c prime. And this is c of x, and this is c prime of x, and this is r prime of x, okay? and you end up answering questions about R. You'll be asked questions about R, asked questions about G, and you'll be given information about H. You'll be given like the function of H. You can look at the areas under H, et cetera, et cetera, et cetera. All right, and this really tied well when we talked about rates. And this is like real world problems where you're given like rates at which things are coming in. You're given a rate which is going out, and a rate is a derivative. Even though they might be like the rate in is capital G of t and the rate out is capital L of t. This is thought of as a derivative. And what's important is that just like we talked about with the accumulation function, areas under rates equal totals. Total changes. So an area under a rate in would tell me how much has come in. An area under a rate out will tell me how much has gone out. And there's a lot of these questions which pertain to these rates, which ask you for like a total amount. Like, how much do I have given these rates? Well, total amount will start with an initial amount. You have to figure out where you started with. You might start with 0, but you might start with something more. Well, then you need to then add the total that has come in and subtract the total that has gone out. Well, total in is an integral of my rate in, and the total out is the integral of my rate out. The initial amount typically is like my total at time 0, and this is equal to my total amount at a certain time. And you'd go from 0 to t and 0 to t. Well, then the next question becomes like, when do we have a max or a min of a total? When is like the total of max? Well, to find a max or min, we'll analyze the signs of t prime. We need to do analysis of t prime. But t prime, this is 0. We have to take the derivative of these accumulation functions, and it ends up being my rate in minus my rate out. So this is like, if this is bigger than this, if my rate in is bigger than my rate out, I'm increasing in my total. If my rate out is bigger than my rate in, I'm decreasing in my total. Okay, if this is positive, I'm increasing. If this is negative, I'm decreasing. So we have a lot of situations where we have a question, and I would advise you to go straight to the rate in, rate out homework videos. To do practice problems for rate ins, rate outs. I'm not certain if we're going to have a rate in, rate out this year. And it's been every single year, but I think we are excluding the accumulation function, which means I don't think they're going to put rate in, rate out. But we did really well on them back in the day when we had this test. Not as well as we did on a straight line motion, but we did pretty well. Okay, that was unit 8. That was unit 8. Accumulation function and rates. Areas under derivatives gives us totals. That's the accumulation function and rates. This is a good unit.